All right, this is on dividing rational expressions. Recall, what do we do when we divide fractions? I tell my students to keep, change, flip. So here's an example where we keep the 1/6, then we change the division symbol to multiplication, and then we flip the second fraction. And then we go ahead and multiply across. So when we multiply across, we see if we can reduce any common factors. So we have a common factor with 6 and 3. So they both can reduce by a 3. So this becomes a 1 and a 2. Then we multiply across. So 1 times 1 is 1, 2 times 2 is 4. We'll do the same thing when we divide rational expressions. So our first rational expression is 4x to the third divided by 9x squared y. And then we're dividing it, so I'm going to go ahead and change that to multiplication, and then I'm going to flip that second fraction. So I've kept the first fraction, I've changed to multiplication, and then I flipped the second fraction. Now, before I begin multiplying across, I reduce any common factors. So I have a common factor of 9, so both of those reduce to 1. I have a common factor of 4, so that becomes a 1 and a 4. We have a common factor of x squared, so that becomes an x and a 1. We have a common factor of a y, so that becomes a 1 and a y to the fourth. So now what's left? We have a 1, an x, a 1, and a y to the fourth in the numerator, so that becomes x, y to the fourth. In the denominator, we have a 1 times a 1 times a 1 times a 4, which is a 4. The next thing we have to do is identify any values for which the expression is undefined. So if we look at the denominator here, we do not want the x to be 0. We do not want the y to be 0. Over here, again, we don't want the y to be 0. So these are the values for which the expression would be undefined. A second one. So we have an x plus 2, so we keep the x plus 2 over the x minus 4. Then we're going to change to multiplication, and then we're going to flip the 3x minus 12 over 1. Now before we begin multiplying across, we see if any common factors. Well, we can change this to a 3 and then x minus 4. We just factored that numerator by GCF. So now we have a common factor of x minus 4 and x minus 4. We multiply across. We have a 3 and then x plus 2 over 1. And we're going to go ahead and multiply across in the numerator, so 3x plus 6 divided by 1 is still just 3x plus 6. This is our answer. And then we look for anything that is undefined. So if we go back to this numerator of x minus 4, we do not want the x to be 4, because if we substitute 4 minus 4 into the denominator, make it 0. And then same thing here, if we substitute a 4 in to that denominator, it would make it undefined. So our answer would be x cannot be 4. All right, we're going to go ahead and keep the numerator and denominator of the first fraction. And we're going to change to multiplication and then flip the second fraction. Now before we begin multiplying across, we look for any common factors. So we have to factor all of these quadratic trinomials. So this first one, by the diamond method, what are the factors of -3 that add to -2, which is -3 and +1. Well, if you can start to do these in your head without the diamond, that's fine. Second one, what are the factors of -2 that add to -1? Well, that will be -2 and +1. The next one, what are the factors of -6 that add to +1? And that's +3 and -2. And then our last one, what are the factors of -15 that add to +2? +5, -3. All right, so all of our quadratic trinomials are now factored, and we're going to go ahead and cancel. But I'm going to first go ahead and see if I can find all my domain restrictions, things that would make x undefined. So if I look here, I don't want that to be a 2 because 2 minus 2 would be 0, so x cannot be 2. Then here, I do not want x to be -1 because -1 plus 1 would be 0. And then here, -5 and +3. And then what we have to do is we have to do the domain restriction from everything in that second fraction. Because what you're doing is you're taking this first fraction and dividing it by the brown fraction. So we have to do all the domain restrictions for the second fraction. So we continue. We did not want that x to be a -3. We don't want that x to be a 2, which we already have up there. All right, so now let's go ahead and begin our canceling our common factors. So we have an x minus 3 and an x minus 3, an x minus 2 and an x minus 2, an x plus 1 and an x plus 1. So what's left is x plus 3 over x plus 5. Now be very careful. Do not cancel those x's. They are not common factors because they do not have a multiplication symbol between the terms. So here's our answer with our domain restrictions. All right. Here's another one. We keep the first fraction. Change to multiplication. And then flip the second fraction. Now we're going to go ahead and start factoring. So this first one, we have to take out the GCF. So GCF would be x squared. So we're left with x squared minus 9. And then the denominator, we have to do the diamond method. So what are the factors of 3 that add to -4? And that is -3 and -1. We did that one. All right, now up here, this is the difference of 2 squared. So a squared minus b squared can be factored as a plus b times the quantity a minus b. So we have x plus 4 and x minus 4. And then in the denominator, we have a GCF of a x I think we have a typo here, actually. This should be an x squared here. So change that to an x squared. So we'll have a GCF of an x squared. So we're left with an x squared plus 2x minus 8. So again, change this last term to an 8x squared. All right, now two of the polynomials have to be continued to be factored. So we have this x squared minus 9 and this x squared plus 8 that have to be factored again. So I'm going to go ahead and just do some canceling of common factors right now. I'm just going to cancel the x squareds out. All right, now I'm going to factor this by the difference of two squareds as x plus 3 and x minus 3. Then the denominator still stays the same, x minus 3, x minus 1. And then the second fraction's numerator will stay the same. And then we're going to factor the denominator by the diamond method. So what are the factors of -8 that add to +2, which is +4 and -2. All right, now let's go ahead and cancel. So an x minus 3 and an x minus 3, an x plus 4 and an x plus 4. And then we multiply across. And then we look for all of our domain restrictions. Right here, we don't want this x to be a 3, so x cannot be a 3. We don't want that x to be a 1. We don't want that x to be a -4. We don't want that x to be a +4. We don't want that to be a -4, a +2. And then up here, we don't want it to be a 0.